Now we are going to discuss about the LS coupling scheme. For example, we are considering a 2 electron system. There are 2 electrons in the p state. So this is a pp interaction. One electron in the p state and another electron in the same p state. So that interaction we are taking. Now for the first electron, the orbital angular momentum quantum number L1 is 1. For the another electron P, again L2 is equal to 1. Now because of the interaction, there is a coupling between L1 and L2. The total L will be L1 plus L2 to L1 minus L2, the modulus. There will be a negative number. So it decreases in steps of unity. So the total value will be 1 plus 1 is 2. Here 1 minus 1 is 0. So the total value is L varies from 2, 1, 0. Similarly, if you take a spin quantum number for the first electron, S1 is equal to half. Spin quantum number for the another electron, that is S2, this is half. So there is a coupling between S1 and S2. The resulting the total S gives S1 plus S2 to modulus of S1 minus S2. Therefore, half plus half is 1, half minus half is 0, so 1 0. So these are the possible values of L quantum number as well as the S quantum. Now, there is a coupling between this L and S. So L and S, the net L value and the net S value, this couples resulting the J value, the total angular momentum quantum. Now this J varies from L plus S to L minus S in steps of unity. Now for you take this value S is equal to 0 and for L is equal to 0, what is the total J? J will be L plus S to L minus S. So here this is 0 only, there is only one value. Any term value is represented by L, here the subscript is J, here the superscript is 2s plus 1, this is called as a degeneracy. So since S is equal to 0, 2s plus 1 is equal to 1, so this is 1. L is equal to 0 means it is a state. L is equal to 0 is the state. So this is S is S and this is 1. The total value of J is equal to 0. So when S0 is the state corresponding to this quantum. Now similarly for the same S0, L is equal to 1. What is J? J is equal to L plus S to L minus S. There is only one value which is 1. L is equal to 1 is a P state. So this is P. The multiplicity of this level is 2s plus 1 is, this is 1. Since it is S is equal to 0, 2s plus 1 is again 1. So this is 1p. J is equal to L plus S, which is equal to again 1. So 1p1 corresponds to this quantum number. For S is equal to 0 and L is equal to 2, total J is 2, this corresponds to 1d2. Now let us choose the another set. S is equal to 1 and for L is equal to 0. This is S is equal to 1, L is equal to 0, J is equal to 1. J will be, this is since L is equal to 0, this is state is S, and since S is equal to 1, 2s plus 1 is 3, J value is equal to 1. So this is 1. 3 is 1 corresponds to this quantum number. Now if S is equal to 1, L is equal to 1. Because S is equal to 1, L is equal to 1. What is the total value of J? J varies from L plus S to L minus S. So this is 2, 1, 0. There are 3 different possible values of J. So 1, 1, 2 corresponds to one state. S1, L1, J1 is another state. S1, L1, J0 means this is another state. So 3, so since L is equal to 1, it's a P state. S is equal to 1, the multiplicity of the level is 3. So 3p, this is 2, one state, comma 3p1 is another state, 3p0 is another state. The 3 state is represented by like this, 3p2, 1, so this corresponds to 3 different states. So these are the different states arises because of the interaction of 2 electrons in the p state, and here we are considering non-equivalent electron. Non-equivalent electron means both the electrons are different principal quantum. So for example, this is 2p, 3p, the different principal quantum. So what are the total number of states arises? This is 3 plus 1, 4, 5, 6 and 7. Then here for L is equal to S is equal to 1, L is equal to 2. S is equal to 1, L is equal to 2. The possibilities of J are L plus S to L minus S. So this is 3, 2, 1. There are different values of J. So these corresponds to 3 states, 3, D, J values are 3, 2, 1. So there are 3 states. So ultimately there are 10 terms. So this is 1, 2, 3, 4, 4 plus 3, 7, 7 plus 3, 8. So 1s0, 1p1, 1d2, 3s1, 3p0, 3p1, 3p2, 3d1, 3d2, 3d3. So these are 10 different terms arises because of the interaction of 2 electrons in the p state if the 2 electrons are different principal quantum. Suppose if both electrons are same principal quantum, we call this as an equivalent electrons. Suppose 2p square. 2p square means there are 2 electrons in the p state. First, both the electrons are having the same principal quantum. Here, there are this electron, there are 1 electron in p state, 1 electron in p state, but this electron belongs to n is equal to 3. Here, this electron belongs to n is equal to 2. Whereas here, both electrons belong to 2 states. In the state, so if you want to arise the term arises because of the interaction of the 2 electrons, we have to apply Paul's exclusion principle because no 2 electrons in the same atom can have all the quantum numbers the same. So N, L, Ml, Ms, they must be different. So you have to apply Paul's exclusion principle. For this we have to use one scheme. This scheme is called as a Brace scheme. Now here you take Ml1. Here 1, 0, minus 1 because this is the L electron. L is 1 electron. So 1, 0, minus 1 is Ml1. For another electron Ml2, again this is 1, 0, minus 1. You add these two, Ml1 plus Ml2, you get the resultant Ml. So this 1 plus 1 is 2, 0 plus 1 is 1, minus 1 plus 1 is 0. So 2, 1, 0. Here 1 plus 0 is 1, 0 plus 0 is 0, minus 1 plus 0 is minus 1. So then you have to sum Ml1 plus Ml2 and you form the table. These numbers are the resultant Mn. Similarly, you take Ms1. Ms1 is half minus half. Ms2 is again half minus half. You add these two. You get the resultant Ms. Ms1 plus Ms2 is your Ms. So half plus half is 1. Half minus half plus half is 0. And half minus half is 0. Minus half is 0. So first you form this table. Now you make a dotted line like this. So this is a inverted L shape. This is also an inverted L shape. So you form this one. As well as you make a dotted line along the diagonal. There is one dotted line here. Here this is a dotted line. This represents the diagonal. These are the dotted line represents this dotted line represents the diagonal line. Now, how to apply Paul's exclusion principle? If you choose one number in the diagonal term, you should not choose a number in the diagonal term in the other term. Because if we choose a number in the diagonal term, and if we choose again, if we choose a number in the diagonal term, then Paulus exclusion principle will be violated. So in order to satisfy the Paulus exclusion principle, we have to, if we choose any number in the diagonal term, you should not choose a number in the diagonal term, the other term. So now let us take M, yes, capital M. M, yes, is equal to plus 1. If you take this number, then what are we? What you have to choose a number ML. Here, you should not choose this number. If you choose this number, Paulus exclusion principle violated. So you should not choose a number in the diagonal term. So if you don't choose this one, the remaining values are 1, 0, minus 1. So if we choose MS is equal to plus 1 in the diagonal term, and then the numbers in the off diagonal term must be chosen. This ML is equal to 1, 0, minus 1. And if we choose MS is equal to minus 1, this is again a number in the diagonal term, then ML must be only possibilities 1, 0, minus 1. Now if we choose MS is equal to 0, if we choose MS is equal to 0, so this is off diagonal term. If it is off diagonal term, you can choose a number. You need not worry about this. Only if you choose a number in the diagonal term, you have to think about the terms which corresponds to the other the diagonal term. So if this is, since it is 0, MS is 0, ML values are 2, 1, 0, minus 1, minus 2 is one possibility. And for MS is equal to 0, 1, 0, minus 1 is another possibility. And therefore MS is equal to 0, 0, this is another possibility. So first you arrive these values, total values of MS and total values of ML. Now let us group these terms. Now if you group like this, MS1 is equal to plus 1, MS is equal to minus 1, and MS is equal to 0. If you group these terms, this is MS1 is equal to 1, MS is equal to minus 1, MS is equal to 0. This corresponds to S is equal to. If S is equal to 1, MS will be pluses to minuses. So plus 1 to plus 1, 0, minus 1. So if S is equal to 1, MS values are plus 1, minus 1, 0. That's why I group these three terms corresponds to S is equal to. Similarly, this side, let us group this term. M1 1, 0, minus 1, 1, 0, minus 1. For this 1, 0, minus 1. So if you group this one, this is ML is equal to 1, 0, minus 1, L is equal to 1. So if L is equal to 1, then only ML will be 1, 0, minus 1. Now let us combine these two. S is equal to 1 and L is equal to 1. So what is the values of J? J will be L plus S to L minus S in the steps of unity. So this is L plus S is 2. This is S is equal to 1, L is equal to 1, J is equal to 2, 1, 0. So there are three possibilities. So these three terms corresponds to the level. Since L is equal to 1, it is a P term. S is equal to 1, it is a 2S plus 1, which is a 3, 2, 1, 0. This is the J value. So 3, P, 2, 1, 0. 3P2, 3P1, 3P0. There are three terms arises because of these terms. Now the remaining terms. Now let us group this one. MS is equal to 0, ML is equal to 2, 1, 0, minus 1, minus 2. This corresponds to MS is equal to 0 means S is equal to 0. ML is equal to 2, 1, 0, minus 1, minus 2 corresponds to L is equal to 2. Therefore, J value is equal to L plus S, which is 2. So 1D 2. Yes, since L is equal to 2 is a D term, S is equal to 0, 2S plus 1 is 1, the multiplicity of the level is 1, and J is equal to 2, therefore 1D2. Now let us group these two. This MS is equal to 0, ML is equal to 0, this corresponds to S is equal to 0, this corresponds to L is equal to 0, the total value is L plus S, which is 0. Since S is equal to 0, L is equal to 0, it is a state. S is equal to 0, 1S, this multiplicity of the value is 1, so 1 is 0, this term. So finally you get 3 plus 1, 4 plus 1. So these are the terms arises because of their LS coupling. So if it is a non-equivalent electrons, you have 10 terms. For equivalent electron, you are having only 5 terms. So this is in order to explain LS coupling, we have chosen these P2 electrons. So if you choose D2, you can there are 2 electrons in the D state. This is non-equivalent, you have to use this procedure. If it is an equivalent, you have to use this procedure. This method is called as a Brace scheme. So for any 2 electron system, the LS coupling can be generated.